Good afternoon, everyone, and welcome to another edition of our online academy here at the Aquarium of the Pacific. My name is Alicia, and we're going to be discovering the Earth together today. Now, I encourage you to participate along with us during this class. There's lots of ways that you can participate. I have my friends Kaya and Allie who are helping us in the studio to take all of your wonderful observations and questions, comments, maybe just some of your ideas that you would like to share with us today. You can do that with the number that you see right below us here. You can also, if you're watching this at another time after we've aired, you can email us at the email address that you see below. Now, for those kids that are participating with us, just make sure you have an adult's permission as normal texting rates do apply. So we're going to be exploring our planet today. We're going to be thinking about our ocean planet really, as an entire system, and how really our Earth system is driven by our ocean, especially our climate. And you can kind of think about the Earth as like the heart of our climate system, and we'll be talking a little bit about that. So behind me here, we have one of our web cameras displaying a habitat. Now, the ocean is made of lots and lots of different habitats, right? This is where a place where an animal lives. And we often think about the animals, but we don't often think about the non-living parts, like the water. Have you ever wondered why some parts of our ocean are different than others? Have you ever thought about why some water it might be warmer or colder around our planet? So we have lots to explore today. I'm going to be using a special app by our National Oceanic and Atmospheric Administration, where they go by NOAA, N-O-A-A for short. They have an app, the SOS Explorer app. So if you just Google NOAA SOS Explorer, you can download this app as well and explore all of the wonderful views that we're going to be taking on our planet. So I'm going to go ahead and grab this iPad that I'm going to be using to control our experience today. And Miss Kaya is going to go ahead and put up our app right behind us here so that we can see it. Now, we'll have a view. Now, as soon as we start making observations here, I want you to start thinking like a scientist with me today. You ready? Scientists are really good about looking closely and looking at details, and it can be as simple as looking for things like colors, shapes, sizes. So here is a view from space looking at our planet. And with this app, I can actually move our planet around a bit so that we can take a view of the entire planet, like I said, as a system, thinking about the whole Earth. Now, as we turn this Earth around, feel free to text in. Do you see any colors? Do you see any unusual shapes? What can you see from this view? Now, in addition to making observations about what we see, we can start to think about why we are seeing these things, right? We can start to make some predictions. For example, looking at these colors, why are they not all the same? What could these colors mean for us? I see a whole lot of blue. Do you see any other colors? So as you're thinking about that, again, if you don't have a chance to text in, no worries. You can write them down. You can tell a family member. You can tell your pets, however you would like to share today. So as we're looking and observing, I want you to think about, how do scientists get this view? What are some of the tools that they might use to look at our planet from space? What do you think? Well, as part of the National Oceanic and Atmospheric Administration, this is a federal agency, so this is part of our government, and they have teams of scientists who specifically study our oceans and they study our atmosphere. And to do that, they put satellites up in our atmosphere. And satellites are really cool. Satellites, you can kind of think of them like big robots in space. And these big robots can look down on our planet with different instruments. And they can see differently with those instruments. So in this case, they can see a whole variety of things. If you're wondering, how can they determine where the clouds are? Or how do they even get this image? Because this image is very similar to what we might see from, again, if you were an astronaut looking down on our planet, which I think is a really interesting view. So these images are a collage. So this satellite might spin around our atmosphere, and those tracks can take 10 hours, 13 hours. Some of them take around 14 hours to spin around our planet, and they look at what we call a swath of the planet at a time, and they gather data or information, and they're able to knit together those swaths of information as they look down on the planet. And those instruments are collecting information using, again, kind of like those eyes to see. They can look for heat, they can look for, they can even detect things like groundwater, which is really interesting. By the gravitational pull, there's really some very interesting, very cool instruments that scientists are using to measure our planet, both in small scale, but also, again, thinking about our planet as a system. Okay, did you think about those colors? Good. So if we're looking at the United States, if we're looking at, kind of where we are here. So if you're watching from Southern California with us, now I know not all of our viewers are from Southern California, but there we are on the map. We're right here. Thinking about these colors, why are we seeing green here and maybe brown in this side? Why are we not seeing all the same colors on our planet? Yeah, so a lot of this has to do with the amount of moisture in our atmosphere. And moisture comes from what? How are we getting some of these greener spots, this vegetation? So this could be anything from a forest, it could be grassy areas. Why are we finding grassy areas in some parts of our planet? And in other parts of our planet, we're seeing some of these really dry areas. So a lot of that has to do with how water moves in our planet. And, I want you to think about why are we seeing these patterns? And, these are questions that scientists have as well. So a lot of this has to do with our oceans. Again, our ocean is like the heart of our climate system. Now, a lot of this has to do with the fact that our Earth isn't just standing straight up. Our Earth is tilted to the side. So it has a tilt to it, and that tilt means that it's facing the sun, and it's not heating our planet evenly. So it's heating what parts of our planet more than others? What would you consider the warmest parts of our planet? Yeah, if you're thinking about this middle section here, so our planet's tilted, so we kind of think about the middle. That middle part is called the equator. And the equator definitely gets a lot warmer than other parts. And we can see that because if we go to our North Pole here, this is the Arctic, we're seeing evidence of that because we see this color white, right? What is that? Yeah, that's ice. So a lot of this is actually sea ice. It's not getting the same amount of sun year-round as the rest of our planet. So it is much, much colder up here. Both the land is colder and especially the water is colder. And at different seasons, you'll have more of the water here freeze and expand. And then as summer approaches for this part of the world, it contracts, it shrinks down. So this is frozen ocean. If we go to the other part of our planet at the very, very bottom, there we go. You can see this is a much larger area. This is the Antarctic. Unlike the Arctic, this is a continent, meaning that there is land underneath. It also can expand a little bit because the ocean that connects to the land also freezes, and it can get bigger and a little bit smaller. And so these areas are much, much cooler. So before, when we were looking at our tropical reef system, we were looking at a part of the planet that receives more heat during different parts of the year. Now, remember we talked about those satellites. So those satellites can actually measure temperature for us in the ocean. So I'm going to go to what we call our sea surface temperature. This is what we call modeled data. So scientists have taken all of the information that they have collected from those satellites. And they are creating kind of like a graph for us so that they can display what we call false imagery. Now, our oceans aren't really this color, right? Our oceans aren't really green. It'd be very pretty, and red and blue. But our planet does have a lot of changes in temperature, and we can use our little scale here to look at that temperature change. So we're saying that the warmer it is, what color might we find? Yeah, we might find red. And just like we would think about blue as being a little bit colder, we can find that again in areas where you're not having a lot of the sun hitting and warming our planet. Because our planet is unevenly heated, that changes a lot of our planet. It actually creates our weather patterns. Now, the difference between weather and climate is something to note. So weather is what we expect to happen every day. So if you check your phone, you're looking at the weather. And that is, we have, our season. If we're thinking about a climate, we're thinking long term. So when we say a climate system is what we kind of expect after, monitoring our planet and collecting information of our planet for years and years and years. So 1 year might be 1 point in a data set. When we're looking at climate, we're looking at thousands and thousands of data points to help us model or predict our future climate. So where do you see, let's make some observations here. Where do you see the warmest parts? Do you see anything interesting? Anything that is maybe unexpected as we look at our Pacific Ocean? So this is all of the Pacific Ocean. So this is the largest ocean here on our planet. You can see it wraps all the way around. So the United States has a Pacific Ocean on the west coast. And if we look at the other coastline, there's Hawaii hanging out in the middle of the Pacific Ocean. You can wave hello. Hello. I want to visit you again soon. All right. And here is the Atlantic Ocean here. So our east coast, and we have some viewers that are from the East Coast. Hello. This is what your ocean looks like. What are some of the differences? So this is a little bit of a smaller area here. But again, we're seeing some of these patterns. So you can almost follow kind of the equatorial line, as we call it. Now I can add on some features here for us, some overlays. So we can take a look at where that equator is and kind of how that is moving. Now, the differences between the temperature of our ocean and our air temperature can really change the way that air moves. So, and that also changes our currents as well. So we have kind of wave action. So you'll see that we have currents that are happening because of the differences between heated water and colder water. We also have wind movement between heated air and colder air. And so we can actually look at this a little bit differently. So if I were to add on here currents, we can take a peek and see how that might change, if I can find it. We might take a peek at it in just a moment. So I think that is a little bit farther up here. So as you're making these observations, feel free to text in. Do you notice anything interesting? Now, we were talking earlier a little bit about these different habitats. And so if you're thinking about a tropical reef, tropical reefs tend to be anywhere from the 70s to kind of the mid 80s in temperature. And there's different kinds of tropical reefs, but what's really apparent between these different reef systems is that they like the temperature to stay pretty much within a small range throughout the entire year. Now, this is a really vibrant ecosystem. So again, when we're thinking about the living and non-living factors, the animals here rely on that nice warm temperature. They don't like it too warm. They don't like it too cold. And even the reef builders here, so these are animals called coral. Did you know that? Did you know that coral is an animal? And it builds a whole shell around itself. That's that's really interesting. So these animals rely on this warmer water. In comparison, let's go ahead and in a moment we'll take a peek at some of our cold water off of our coast, a cold water habitat called a kelp forest. So a kelp forest habitat relies on just the opposite. It likes nice temperate or colder water. And the kelp here do not do well if there is a warming event. So the animals that build our kelp forest, and we actually have a webcam, they call it a forest because there are animals that live at all levels of the kelp forest, kind of like in a rainforest. So earlier, when we were taking a peek at our currents in our system here, I might not be able to find my what I was looking for here, but that's okay. I did want to talk a little bit again about how this might impact us in our weather systems. I also wanted to talk a little bit how that might impact animals, especially animals that take advantage of these different habitats by migrating. Okay, so here's our currents model up here. I'm going to load that up for you. And it's pretty crazy. You ready for this? There's some great colors that are happening in this model. So again, you're looking at the differences between our air temperature and our water temperature. And there is movement happening because of this. Some of the spinning that you're seeing is actually from the Coriolis effect, which is because the Earth itself is spinning. So you'll see a lot of these little eddies that are happening here. So this is pretty much the flow of water through our ocean driven by temperature changes, driven by the fact that the Earth is not evenly heated. And look at the comparison between, so this is the United States. I know it's a little hard to see. I'll go ahead and maybe add I might make it a little bit easier for us to see on here. So again, this is us here in California where we have that nice temperate water. So you can see it's kind of in that green. Comparing it to the East Coast, what colors do you see? Yeah, you see this red? Do you see how it's moving quickly? A lot of that has to do, again, with that temperature. And if we follow this current all the way up, so this current moves up, this is why up in Europe, they actually have a nice temperate coastline, is because this flow of warm water kind of jetting up into these European countries. If we look over here in Canada, it is much cooler. You can kind of see these little blue wisps that are here and around the coast here. That is much colder than, again, some of our eastern seaboard here. Now, animals can take advantage of that. In fact, one of those ocean animals that I always think of when we talk about migrations are whales. We have a whale that passes our coastline. They actually start up here in the Aleutian Islands, and they'll make their way into the Bering Sea. So this is the Bering Sea. This is Alaska. These are the Aleutian Islands here. And there's a lot of really great food availability for these gray whales. So gray whales will take a couple months to really eat. They're called mudsuckers. They will actually turn to the side and they suck up mud and filter through to get little tiny invertebrates at the bottom. And then those whales will get nice and blubbery and thick so that they're ready for their migration. And then they will travel 7,000 to 8,000 miles all the way down the coastline, all the way down into the safe lagoons of Mexico. And so these nice warm lagoons down here, you can see the temperature change, are perfect for them to have their babies. So when whales have their babies, they don't have that nice layer of thick blubber around their bodies. They need to feed off of mom to get a nice layer of milk, and then they can build up their blubber and then again make that 7,000 to 8,000 mile trek all the way back up to the Bering Sea. And so they're taking advantage of two very different habitats. One that is nice and warm to have their babies, and the other that has a wonderful food supply. Now, when we're looking at our planet, so again, we can think about our planet as a whole. We can also kind of help tell the story of the different habitats that are created because of these temperature changes. So looking at our planet as a whole and looking at these changes, we can kind of tell the story of how hurricanes happen as well. So hurricanes happen when the temperature of the ocean is more than 80 degrees for as deep as 100 feet. That's really warm. Normally that sea surface temperature, again, is only a couple feet that it gets warm. But if we're thinking about the warmest parts of our ocean, again, if we go back to kind of the warmer periods of time, if we look for red, we can actually map out where we might find hurricanes. I'm going to actually go back to the sea surface temperature, which will show us just a little bit easier this data set. So as this loads, I want you to look, where might we find, if we know that we need 80 plus degrees in order for a hurricane to happen, where might we find hurricanes, let's say, in the Pacific Ocean? Are we going to find them off of our coast? Probably not. It's not very common that we would find a hurricane off of the Southern California coastline here. You can see that we have, luckily for us, a nice cool current that comes all the way down from Alaska and makes its way down our coastline, giving us this nice temperate water. But we go a little bit farther down, we can see this range here. Again, this is by the equator. And then seasonally, as we heat up, it takes the whole summer to heat up. You know, hurricane season starts at the end of summer because we need to kind of ramp up that whole ocean heating for that time. This band here will actually expand up. So in seasons that are a little bit colder, like winter, this heated band actually moves down, and then in summertime, it expands. And that's, again, the position of our planet and how that rotates facing as it, the sun is facing it. So it heats it differently at different times of the year. And that's how we get our seasons, right? That tilt. So if I were to show you really quickly, scientists have been trying to better understand hurricanes. They want to be able to predict and model these hurricane tracks so that we can be best prepared for early warning for hurricanes and to understand how they may impact us on land. And so what they've been doing is, you can see here, these are hurricanes that have happened between 1950 and 2005. And they've dotted out depending on kind of the severity of the hurricane. So hurricanes are put into categories depending on how fast the hurricanes move. So that can range anywhere from, it says down here, let's see, tropical storm level is 39 to 73 miles per hour. And then as soon as it gets to 74 miles an hour plus, that's a type 1 hurricane. Type 5, or category 5 hurricanes range between 150 to 200 miles per hour. And they say that if you were able to capture the energy from a hurricane 5, category 5, you could take that energy and power the entire United States for a year. So there is a lot of energy packed into a category 5 hurricane. Those are typically pretty rare, but I want to look to see where scientists have mapped them. So again, the reds are those higher, faster moving type 5 hurricanes, and then tropical storms, and then tropical depressions. I always think tropical depression sounds funny, like it's sad it's not quite a hurricane or a tropical storm yet, but that is one step below the tropical storm. So as it builds in power, again, this is building because the temperature of the ocean is much warmer than the temperature of the air. And that happens again as we go into fall. You still have a very warm ocean, but you have a very cool atmosphere as we transition to fall time. And that's why we get a lot of hurricanes in that fall season. And so you can see this track is actually very similar to what we were observing right earlier when we were saying that the hurricane systems kind of match the sea surface temperature. Now, if we look at the East Coast here, instead of being concentrated, the hurricane paths kind of shoot up. And so we have, the reason for this is, again, do you remember how the seas currents were moving? They had those little eddies that were circling and moving through. So the path that's being taken here, a lot of it has to do with what we call the Gulf Stream. And that was that little line of really, really warm water shooting up and kind of into the upper parts of the Atlantic Ocean. And so during hurricane season, although we have a lot in the Pacific, those Pacific hurricanes, some of them do actually hit, places like Hawaii. So the Hawaiian Islands are in the middle of the Pacific, and sometimes it will range high enough to make land at on those Hawaiian Islands. But a lot of them happen in the Pacific Ocean here off of, I would say, closer to the west coast of the United States, but we don't feel those effects. As we start to move farther towards places like Japan, Indonesia, Micronesia here, we are looking at areas that are affected by hurricanes because it is a little bit closer into the path, and also the currents where you're having warm water push and feed into those hurricanes. Now you'll notice that there's a gap, right? So we can have hurricanes lower. So we have hurricanes above and below the equator, but they don't cross. And that's something I think is really evident from our data sets here. All this data is showing us that you can have a hurricane in the northern hemisphere or the southern hemisphere, but you don't have really a cross on the top. And that's, again, because of the way that our currents are moving. All right, so we were taking a look at these different ecosystems. So what have we talked about so far? So we've talked about the Earth determining, as we were looking at before. Let's go back to our first image here. So as we've been exploring our planet, we're seeing that our planet is really affecting things like our climate. So when we think about moisture on land, we were talking about that a little bit earlier. What's driving that water cycle? What's creating a lot of that water that's happening? Yeah, evaporation, right? So when we think about climate, again, it goes back to that uneven heating of the Earth's surface. There are some areas that are creating more evaporation, and then we're seeing it being stored in our atmosphere in clouds. And the clouds are moving through our planet because there are temperature differences that are happening that's kind of pushing our air into some of these locations. And those locations, again, are going to be closer to our, go ahead and change how this looks a little bit, closer to the equator. If we get farther away from the equator, it's a little harder for scientists to predict where that rainfall is, but it is a little bit more predictable in some of these places that are closer to the side. Now I want to show you, we were looking at the Earth always in daytime, but that's not true, right? We're thinking about the cycles of our planet. This side here is going to be nighttime. I'm going to go ahead and just kind of show you what that looks like by adding an overlay so you can kind of see what that looks like. So our planet, again, isn't always daytime. You're going to see a little bit of that daytime, nighttime as we migrate through here. All right. So maybe I'll end with our Blue Cavern webcam, which we'll have Miss Kaya put up for us here. I'll put my iPad down. So thinking about our whole planet as a system, and then as you think about the different habitats that are found throughout the ocean, thinking about how it's heated, where nutrients come from. When we're looking at those currents are also bringing in a lot of nutrients for the animals that you find here, and that feeds the food web. If you were watching one of our earlier programs and we were talking about food webs, a lot of the the kelp in here and the algae, those producers, they need those cold water nutrients in a kelp forest to come through currents. Some of that's through wave action. Some of it's through what we call upwelling. And again, these features are all tied together, those living and non-living features. Well, I'm going to go ahead and wrap up. I hope you enjoyed learning a little bit about our Earth as a whole system. And again, if you have any questions, feel free to email us at live@aop.org. Thank you so much, everyone, for joining us. And we have one last program today. We have programming throughout the week. Take care.